Hello, our dear viewers. Welcome back to our YouTube channel. This is Hope Chemist. Today we are going to talk about benzene diazonium salts, and under that we shall look at the Sandmeyer reaction. Please, I would like to request you to like, share, comment, and subscribe. Share to your friends who are chemistry gurus, so that we can have a good number of subscription and a good morale. So benzene diazonium salts, these are formed through a reaction of aminobenzene, which we can also know as aniline, with sodium nitrite in the presence of concentrated hydrochloric acid at low temperatures, which we can say basically below 10 degrees Celsius. This reaction involves the addition of a nitrogen atom to the already existing nitrogen with formation of a triple bond between the two nitrogen atoms and the loss of water to form a salt as shown. In this reaction here, we have aminobenzene aniline, sodium nitrite with HCl, which should be concentrated, although it is not indicated here. So at a temperature below 10 degrees Celsius, we form benzene diazonium salt, sodium chloride, and water. So this compound is known as benzene diazonium chloride. The benzene diazonium chloride acts as an intermediate, leading to the formation of many benzene substituted products at the same carbon atom, which was initially having the amino group, which we can call as ipso addition. An example of this is when we get the diazonium salt, we dilute it with water in the presence of an acid and we warm. This acid here may be sulfuric acid, which may be supposed to be aqueous, and we warm just slightly above 10 degrees Celsius. So when you treat this diazonium salt with water in the presence of a little acid, we shall be forming phenol. So at the same position where we are having the aniline or the diazo group, we shall have our phenol and we shall be losing nitrogen in our example. Then we are going to look at the Sandmeyer reaction. This reaction was created by Sandmeyer, a scientist known as Sandmeyer. So when we get a benzene diazonium salt and we treat it with nucleophilic reagents, the benzene ring undergoes ipso addition with release of nitrogen gas. So this reaction here follows a free radical mechanism which involves a single electron transfer, as we are going to see in our next slide. And the diazonium salt is reduced to a diazonium radical. Then we have loss of nitrogen, leading to the formation of the aryl radical and the ligand transfer. And then we shall have our catalyst being regenerated, as shown below. So when you look at this mechanism, in step 1, we are having copper 1 chloride. This is going to be our catalyst. It will react with the diazonium chloride. The copper will lose 1 electron. As we know, in the copper 1, it is not stable enough. It is in copper 2 where it will be a bit stable. When it donates 1 electron, so a single electron is transferred from copper to nitrogen, and this copper here, we shall have an oxidation. So we shall have copper 2 chloride. So that is the single electron transfer from copper to nitrogen. Then in step 2, we are going to lose the nitrogen, and then we shall form the aryl radical. And then in step 3, we shall have the ligand transfer from copper, and then we go back and we regenerate our catalyst, which is copper 1 chloride, and one of the chlorine which was there initially is now substituted in the same position where our diazonium salt was. We have several examples. These examples, when we treat the benzene diazonium salt with potassium iodide, we get iodobenzene. We have seen this one when we treat it with HCl and copper 1 chloride, we form chlorobenzene. Hydrogen bromide, copper bromide, copper 1 bromide, we form bromobenzene. Hydrogen cyanide and copper cyanide, copper 1 cyanide, we form benzonitrile. So other examples there. So these examples were suggested, or this reaction was suggested by Sandmeyer as earlier on communicated. In conclusion, when you look at this benzene diazonium salt, when we also treat it with phosphoric acid, we get a product which is benzene. So that means the diazonium is broken off and we replace the hydrogen which was previously there to bring the benzene back. So benzene diazonium salt is also important in the formation of azo dyes when reacted with benzene. For example, when you look at this reaction here, the benzene diazonium chloride reacting with phenol, we shall form 4-hydroxyazo-benzene, which is a dye and it is colored. Other examples are there, so that one you can go ahead and read about the coupling reactions, or we shall have a session talking about specifically the azo dyes and their importances in the future. So I would like to thank you for listening and watching this video. I would like you to subscribe, like and comment for areas of improvement. Thank you. Let us meet again in my next video. Hope Chemist for you. Thank you.